Welcome back. In this video, we are going to talk about method reference and constructor reference. What is method reference? What is constructor reference? What are the benefits? And last but not the least, how we are going to use method reference and constructor reference in our day-to-day projects. So let's start. To understand the concept of method reference, let's take an example. In a project, there is one class named A is there. In that class A, there are 5 different implementations was done as per the requirement of the project. After some time period, we needed some new requirement, and according to the new requirement, we have to add one more class. Let's say class name will be B. In that new class B, we have to create 4 different methods with different implementations. After developer wrote 3 methods, when he started to write 4th one, then he found out that B_test4 method properties are pretty much similar to class A's second method, that is A_test2. So what happened here? Code repetition happened. In class B's 4th method and class A's second method, properties are same. To avoid this kind of a code repetition, Java 8 people introduced method reference. Now, after method reference, what it will happen? Whenever a user will call this B_test4, then developer will throw this, or you can also say invoke A_test2 properties inside this method. This concept of referring one method to another method is known as method reference. And in the same way, how constructor reference works. If class A constructor have some properties and class B needs similar properties, then instead of writing class B's constructor properties again, what he will do? He will invoke the class A's constructor properties inside class B. This is known as constructor reference. The main advantage of this method reference and constructor reference is code reusability will going to happen. Now we are going to see how we will use method reference and constructor reference in real-time scenarios. So let's start. Functional interface. Now what we will do? We will write one functional interface. Let's say interface name will be interface A. We already know the properties of functional interface. We will keep only one. We can keep only one abstract method. So we are going to write public void display. So we have kept only one abstract method. The name of that abstract method is display. Now we will write one more method, and inside test1 class, and name of that method will be public void display _1. Method name will be, we will keep display _1, and inside in this method we are going to write one statement. Let's say statement will be method reference in Java 8. So what we have done here, we have written one functional interface and we have written one more class inside test1 class. Now what we will do, we will try to invoke this display _1 test class to inside this functional interfaces abstract method display. How we are going to do that? First of all, we are going to write interface name. The reference name will be check. Now instead of writing lambda expression, what we will do, we will invoke display _1 method to display. How we will do that? To write a lambda expression, first of all, this method is a non-static method. To call a non-static method, we need to create a object reference. So let's write object reference of test1. We will do that. We will do that with the help of a new operator, test1. Now what we will do, we will call this test1 double colon, and after that we will write this method name. That's it. Now what will happen? Internally this code, this statement is automatically invoked inside this abstract method. Let's call this abstract method check dot display. When I'm executing the code, then it will execute method reference in Java 8. Let's execute this code to verify our output. Method reference in Java 8. So what happened internally? Internally, this display underscore one method is invoked inside this interface A abstract method. Now let's understand few concept of method reference. In method reference, if we want, we can take different type of access modifier. If we want, instead of non-static, we can take static. That also it will accept. We can take different types of return type. We can take different types of argument. For example, here I will accept int a, and here we can take float a, but we need to keep one thing certain, that number of argument should be saved. If this method is taking one argument, then this method also should take only one argument, not more than that. We can change access modifier, we can change return type, we can change type argument. For example, here I am taking int a, here I am taking float a. It will work. It will work, but the number of argument of both the method that you are invoking or referring, it should be same. Okay, this is one of the most important concept you need to keep in mind whenever you are going to use method reference. Now what we will do, here we have written public. Now we will change from here public to private. You can see that there is no compiler error is thrown. Let's execute the code again to see that if we change the access modifier, it will work properly or not. You can see that code is working fine. That means we can change access modifier. It will not be a big deal. Now what if we change the return type? Instead of void, I will change it here int, and here I'm going to return 0. Again, I can see that there is no compiler error is thrown. So let's execute this code again. Again, no issue. Output came exactly same. Now, from these examples, we can understand that we can keep different access modifier. It will not create any type of a problem. We can keep different return types. It will not create any type of problem. Now, what we will do, we will take another example, and in this example, we will try to pass two different arguments, and we will see the output of that. Again, we will write one functional interface, and in this functional interface, we will keep name as interface B. We will take different argument and we will try to add those arguments. So let's keep the abstract name will be add. So it will be access modifier will be public. Return type I'm keeping as void. After that, I'm keeping method name as add, and here I'm going to pass two different arguments, int a, int b. Now I will write one more class, public void add int a, int b. Here I will change return type to void to int, right? Int return a plus b. Here also I'm going to change return type int. Okay, now what we will do, we will try to invoke this add underscore one method to this abstract method of b, that is add. Let's do, we'll keep the interface name b. Now we will try to invoke. We already see how we are going to invoke. To invoke a non-static method, we need to create a object reference with the help of a new operator. Now we will call this method t2 double colon, and after that add underscore 1. So now internally what it will happen, internally whenever I am using that object reference double colon with the method name, then internally it will invoke this functional interfaces abstract method. We can also say that method reference also can replace lambda expression. It is also useful if you wanted to replace lambda expression. Now let's call this b reference system.out.println. It should be addition b dot, and here I am going to pass two arguments 10, 20. So I have called this abstract method, and here I am using method reference to invoke this property to this abstract method, right? And here I am calling with this abstract method with two different arguments, and I given argument name is 10, 20. So now let's execute this code. Answer should come as 30. So answer came 30. Now what you can see that we have taken an object reference to that double colon, and after that we have called this method. Now instead of writing this object reference, we can directly call with the help of a new operator. What we will do, we will just use new space test2, and we will replace it with object reference. It will work exactly the same way. We can see that there is no compiler error. Now let's execute this code again. Addition 30. Output came similar. Now what if I will change this non-static method to static? So to call, we have seen that how we are going to call non-static method. We can call from the new operator, and also we can call from object reference, right? But if you wanted to invoke static method, then in that scenario you have to use class name double colon method name. So instead of new operator, we are going to use class name. This is the way how we are going to call static method. Now let's execute the code again. Addition 30. So we understood how we are going to call non-static method. We also understood how we are going to call static method. Let's take one more example to understand the concept of method reference in a much more deeper. Let's write a functional interface, and now I will keep functional interface name is interface C, and in this interface C, we will accept two arguments, and we will keep method name as multiply. Public int multiply, argument name let's say int A, int B, and inside test3 we will write one method, and that method will be non-static. Public int, let's say method name will be multiply underscore 1, and here I will pass again two arguments, int A, int B, and I will return into B. Now in method reference, what I will do, I will invoke multiply underscore 1 to multiply. How we are going to do that? First of all, we are going to keep interface name, reference name. It's a non-static method. So we have seen with the help of a new operator or object reference, we can call non-static method. So let's use new operator, new. After that, method name test3 double colon, and after that method name. So what I did, I invoked multiply underscore 1 method to multiply. Now let's call this abstract method. And here I am going to pass two different arguments. Let's say a equal to 10, and we will keep b as 10 also. So if it will invoke properly, then in that scenario 10 into 10 answer it will come as 100, because this method property is going to invoke inside this one. So let's execute this code to verify our output. Multiplication equal to 100. Output came exactly the same the way we predicted. Now we will take one more example. In this example, what we will do, we will try to invoke pre-existing interface which have only one method. For example, thread. Let's see how we are going to use that. Let's write one method here. And inside here, I'm going to pass a statement. Let's say statement will be, now what we are going to do, we already know that the thread has one interface name is runnable, and that runnable has only one abstract method, and abstract method name is run. We'll try to invoke this display underscore check method properties inside that run method. How we are going to do that? We will do exactly in the same way the way we have done in the previous examples. First of all, we will write the interface name. Now here, what we will do, we will invoke this static method double colon method name. If it's not a static method, then if it is a non-static method, then in that scenario we would have used object reference or new operator, or from the new operator directly. Then now what we will do, thread, let's start the thread now. You can see that there is no compiler error is thrown. Now if we have written the code properly, and if the compiler invoked display underscore check properties inside run method, then it should print method reference with thread implementation. Let's execute this code to verify that method reference with thread implementation. So that's how we are going to use method reference in Java 8. Now we are going to see that how we are going to use constructor reference. To understand the concept of constructor reference, let's write a functional interface, and in this interface, functional interface, we will keep name as interface D, and here we are going to write one abstract method, and in this abstract method we will write return type as test5, and let's say the name of that method will be display. Now this test5 class, we will write a constructor here. Here I am going to pass some statement. Let's say constructor reference implementation. Now what we have done here, we have written one functional interface, and the return type of this functional interface is test5, and after that we have written a constructor of test5, constructor reference implementation. Now what we will do, we will try to invoke this constructor reference to inside here. How we are going to do that? We will use the same way the way we used in method reference. First of all, we are going to call this interface D, and to call a constructor reference we need to use new operator. How? Class name double colon new. That's how we are going to call constructor reference. We need to use new operator. This is the syntax of calling a constructor. Class name double colon new. That's it. And internally what it will happen, this property of constructor reference implement inside this interface abstract method. Let's call this interface abstract method. How we are going to do that? Now let's execute this code. Constructor reference implementation. So we have seen how we are going to call constructor reference. the main job of a constructor is to initialize values, right? So let's say I'm going to initialize some values inside here in test5 class, and we will see how we are going to call that. So how we will do that, let's say I will keep two variables here, int a and int b, and inside constructor I'm going to initialize those values. Let's say I will keep int a equal to 10 and int b equal to 20. Okay, so what I have done, inside this test5 constructor I've initialized those values, and here in this code I have invoked this constructor to inside this method, right? So if I wanted to call, how we are going to do that? Interface reference name dot method name, and after that from method name dot again dot a. So that's how we are going to call initialize variables if we needed to call from with the help of constructor reference. How we did that? We called interface reference. After that we called that interface reference abstracted method dot a. So execute this code, then what will be the output? In one here it will come as 10 and here it will come as 20. Here I have done a mistake. I have initialized these values again. Okay. Let's execute this code to verify our output. 10 and 20. So what were the things that we saw? We saw how what is method reference, what is constructor reference, what are the benefits. We saw that the reason behind method and constructor reference was introduced, so code reusability can happen. And we also saw the different ways to call method reference. If it's a static class, then with the help of a class name double colon method name, from that we are going to call method reference. If it's a non-static class, then we are going to create object reference with the help of a new operator. We can directly call from new operator double colon dot method name, we can invoke method reference. After we saw how we are going to call constructor reference. To call a constructor reference, what we have to do? Class name double colon new operator. From that we can easily use constructor reference, and after that we have seen that if the initialized variables are, if some sort of initialization done in the constructor, and if you have wanted to refer in some other method with the help of a constructor reference, how we can do that. So this is the end of this video tutorial. In the next video we are going to talk about one of the most important topic of Java 8, that is streams. So keep watching Java 8 tutorials. Thank you.